Module 11, Instant AP, Intrusion Protection System, Intrusion Detection System. This module covers why we need intrusion protection and intrusion detection, the various classifications for other Wi-Fi devices, some different attacks that can happen, how rogue detection works, containment options, some IDS monitoring and commands. In any network, intrusion detection is of paramount necessity because attacks can originate from outside or even inside the network. The most important IDS function offered in the Aruba Instant Network are the ability to detect rogue APs, interfering APs, and other devices that can potentially disrupt the network operation. Aruba Instant can even warn you of various forms of attack against the network. IDS classifies APs into three types. Rogue. AP is considered to be a rogue AP if it is both unauthorized and plugged into the wired side of the network. Interfering. AP is considered to be an interfering AP if it is seen in the RF environment but is not connected to the wired network. While the interfering AP can potentially cause RF interference, it is not considered a direct security threat since it is not connected to the wired network. However, an interfering AP may be reclassified as a rogue AP. Interfering clients. Devices within the IAP's radio frequency area that are not associated to an IAP. They can cause interference in the radio band. Valid would be one of the IAPs in this cluster. The IAPs can be set up to detect an entire range of different types of attacks on your network, like the following. TKIP replay attack. It leverages vulnerabilities in the TKIP. Chop attack, which allows an attacker to interactively decrypt the last n bytes of plain text in a WEP encrypted packet. This is just a small list of many attacks that the IAP can be configured to detect. If you require more information on the forms of attacks, you can easily research them on the web. An AP is considered to be a rogue AP if it is both unauthorized and plugged into the wired side of the network. For the IAP to see the rogue, it must be in the same VLAN as the IAP. The IAP collects the MAC addresses from the wired side and compares this with what it sees on the wireless side. In the example, AP1 can see the rogue AP wirelessly and wired. If you are managing your IP networks with an Airwave, then Airwave has an extensive rule-based classification system. You can invoke the WIP system by selecting IDS from the More drop-down menu. The Detection tab provides two options, Infrastructure and Clients. Within each of these options, there are several default levels that enable different sets of policies. An administrator can customize, enable, or disable these options accordingly. For infrastructure, off, only rogue classification is completed. Low, will only detect 4 types of classifications. Medium will add an additional 2 classifications. And high allows for all classifications the IAP is capable of processing. For clients, off, no detection is completed. Low, only detects a valid station from misassociation. Medium, will add an additional 7 detections. And high, will enable every client detection. The second tab is the protection settings. There are 2 sections that you can select, Infrastructure and Clients. For infrastructure protection policies, there are 4 possible protection policies you can select. Protect SSID, rogue containment, protect from ad hoc networks, protect AP impersonation. For client protection policies, there are 2 choices. Protect valid stations, protect window bridge. By clicking on Show Advanced Options, you see the containment methods. When you select containment methods, the following types of containment mechanisms are possible. Wired containment. When enabled, the access point will generate ARP packets on the wired network to contain the wireless attack. Wireless containment. When enabled, the system will attempt to disconnect all clients that are connected or attempting to connect to the identified access point. Within this option, you have three additional choices. None. Disable all containment mechanisms. Deauthenticate only. The AP or client is contained by disrupting the client association on the wireless interface. Target containment. The access point is contained by luring clients that are attempting to associate to it to a tar pit with a fake channel and fake BSSID. In the firewall settings under Security, you can set the protection against wired attacks in three sections. Drop bad ARP will drop fake ARP packets when enabled. Fix malformed DHCP. The IAP will fix the malformed DHCP packets when enabled. ARP poison check. This enables the IAP to trigger an alert which will notify the user about the ARP poisoning that may have been caused by a rogue AP. The IDS link gives you a list of all devices that have been discovered by the IAP cluster. The devices are listed as interfering or rogue. You can click on the Where pin to see which IAPs can see this foreign device. You can also see all foreign clients. These are devices that are within radio range but are not associated to the IAPs. If the IAPs are reporting to Airwave or Central, then you can get a visual RF map of the IAP cluster and the location of the foreign devices. From the More drop-down menu, you can select Support and issue the command Show AP Monitor AP Table. This command will list all the BSSIDs that can be seen by the IAPs in this cluster. The AP type will list whether the AP is valid, interfering, or rogue. Here's an example of the AP log security command. Here we can see that the SSID CASA1 has been classified as rogue. We also note that we have an anomaly of the CTS and RTS. This could be an attack. We need to check if our values are set too low. Also, we can see that we've received a malformed frame from a client. You can issue commands from the CLI interface. The command Show IDS Rogue AP MAC address displays the information about how a rogue AP was classified and why. In this example, the rogue has an ending part of the MAC address as B480. The IAP that discovered the rogue is BADA. The reason for the classification was an exact match on the default gateway 7801. In this example, the rogue has the ending part of the MAC address as 038A. The IAP that discovered the rogue is BADA. In this scenario, the rogue AP's BSSID is one smaller than the wired MAC address of this device. The IAP has seen 038A in the air and has seen 038B on the wired side. Therefore, we think it is the same device. In this module, we saw why we need IDS IPS security. We looked at the classifications. We looked at a few different attacks. We looked at how rogues are detected. We saw some IDS monitoring and commands. And we looked at some containment methods.